Hello everyone, I'm going to solve with you the angles activities. Activity 1. Measure these angles with a protractor and name them. I'm so sorry, but I don't have my protractor here, so I will just give you the solutions. This is an obtuse angle. It measures 120 degrees. It's greater than 90 degrees and less than 180. So this is obtuse. The second angle is a right angle. It exactly measures 90 degrees. Next one is an acute angle. It's less than 90. I'm pretty sure that this angle was 45 degrees. You can check it with your own protractor. The last one is a straight angle, exactly 180 degrees. Attention to the spelling. Right and straight have T's at the end. Activity 2. Draw an example of the following angles. Remember that to draw an angle, the first thing we have to do is to start making a ray. You can use the protractor to draw this type of angles, or you can use the triangular set of squares. This is the tool I'm going to use. So I will start making the baselines, the rays, in all of them, using any straight edge tool. This is a straight angle, exactly 180 degrees. Obtuse angle 120, what I'm going to do is to construct a minus 60 degrees angle, that is a 60 degrees angle clockwise direction. So I will set my 60 degrees angle of the 30-60 degrees triangle, and I will draw this ray. This is 60 negative, so it means that this is already 120 degrees. You can already erase this little piece of ray. To construct a right angle, you just have to make a perpendicular line at one of the end points of the rays, at the vertex of the angle. This is already 90 degrees. To make an acute angle, 75 degrees, you can make the addition of the angle of 45 degrees of the 45 degrees triangle and the angle of 30 degrees in the 30-60 degrees triangle. You just have to match the two vertices together and one of the edges of the tools on top of the ray. This is already 75 degrees. To make an acute angle 15 degrees, you will make a subtraction. That is, once you have the angle of 45 and you put the angle of 30 degrees on top of it, the spare angle, this is already 15. So I will construct my angle of 45. Very softly. Then I will set on top of it my angle of 30. And the spare piece. This is my acute angle of 15 degrees. If you're not very skillful drawing arcs, feel free to make these lines using the compass. Activity 3. Name these angles. In this activity, we have two angles in different situations. We have two intersecting lines, and these two angles are one on the opposite side of the other. Here, the two angles, they are one next to each other, one in front of the other one next to each other. So we have to name them according to these relationships. The first two is what we call vertical angles. on opposite side of the vertex. We have the same situation in the third picture. They are also vertical angles. In the second picture, they are adjacent. It means that they have the same vertex, but they share one of the sides. They don't overlap. We have a very similar situation in the last picture. They are adjacent. They have this vertex in common and they share this side. Activity 4. Construct its complementary angle. We have a given angle A and we have to construct its complementary, that is another angle that has a common vertex that share the same size, but when we put them together, the measurements are up to 90 degrees. So basically what I have to do is to construct a perpendicular line to this ray. I will use my set of squares to make this construction. Perfectly drawn at 90 degrees. So this is B, the complementary angle to A. Activity 5. Construct its supplementary angle. So we have an angle given, that is angle A, and we have to construct its supplementary. That is another angle that has exactly the same vertex and that shares the same side, but when adding the two measures together, we get 180. The only thing we have to do is to extend with any straight edge tool this ray on the opposite direction. This angle we get here, angle B, is the supplementary angle to A. Activity 6. Copy these angles. We have angle A, and then we have a given ray. Then we have angle E, and then we have a given ray. So what do we have to do in this activity? We have to copy or transport an angle onto the given ray. How does it work? You need the compass and you need the ruler. You will start opening the compass at any length and you will draw an arc, center point, the vertex of A. So you can open the compass any convenient radius, and the arc should intersect the rays of the angle. Exactly with the same measurement, you will set the point of the compass at the end point of the ray at O, and you will construct the same arc. Draw it big enough if you are not sure how big it is. The arc on angle A intersects the rays at points 1 and 2. This is already point 1 prime. Open your compass between 1 and 2, that is, set the point of your compass at 1, set the letter of the compass at 2, make a little mark to make sure that you have the right measurement, and then draw an arc from point 1 prime on top of the arc. This is point 2. To copy angle A on this given ray, you just have to connect the vertex of the angle with point 2 prime. This is angle A copied. We don't usually use the protractor to copy an angle because it's not precise enough. This is why we use the compass and the ruler. To make the construction or to copy angle E, we apply exactly the same procedure. Open your compass, at any radius and draw an arc that intersects the rays of the angle at 2 points, point 1 and 2. Exactly with the same radius, make a second arc on top of the given ray. This is already point 1 prime. Measure the chord of the arc, that is, measure the distance between 1 and 2, and then draw an arc from point 1 prime that intersects the previous arc. This is point 2 prime. Connect the vertex of the angle with point 2, and this is angle E, copied or transported.